Yeah, hi everyone. Thanks for joining our session. We're going to talk about LLM query benchmarks. So we're going to compare how good or bad LLMs are in translating natural language into Cypher and SQL queries. And the company that we present is the Time to Act group. And I want to say some words about the company first. So this is an IT services provider, which works under a mixed brand strategy. So we have several companies that act independently in this group, but we also deliver projects together, which makes it interesting because we have a lot of specialized companies for different technologies. And with that, I want to get started with the agenda. So we're going to start by telling you how the idea came across that we implemented this benchmark. Then we'll tell you about the data set and the questions that we used, and at the end, show the interesting results that I got. And well, maybe some words to myself and Rinat. So I've already been involved in the Neo4j community for several years now, and so this is why I'm covering the Cypher part, and Rinat is going to cover the SQL part in this presentation. So let's dive in with the idea. So Rinat.
Okay, so the idea is that in the real world, companies and businesses, they frequently want to work with complex data sets. This can be data analysis of a complex mainframe code, or analyzing data warehouse in a company with lots of databases, or running dependency and risk analysis in a complex enterprise. And as of recently, because of LLMs, it became potentially possible to let LLMs handle queries like that. And potentially, LLMs have the capability to support data scientists to write complex queries faster, or even support business stakeholders in writing fairly complicated queries. And at Time to Act Group, we've seen business assistants that have been already employed successfully to that. But they were working mostly with relational databases. And now that they were at Nodes conference for the Neo4j, the idea was if it's possible to work in the direction of graph databases and enable people without query language or domain understanding to access and query fairly complex data. So that's, as Elena calls it, dream of the self-service pipeline. Could you switch to the next one? Yeah, so you can cover this one.
Okay, so well, if we look at the capabilities of LLMs to translate natural language to any other language, then we have to ask ourselves what the quality actually depends on. So what kind of wheels do we have to turn in this example? So first of all, of course, we have the large language models. So it depends highly on what kind of model you choose and what kind of data it has been trained on. Secondly, well, of course, it depends which language you're going to choose into which you're going to translate the natural language questions that you have. Furthermore, well, the schema complexity plays a role. If you have a very simple schema, maybe the questions will be translated better. But if you have a complex schema, they might be translated not so well. Well, and also, independently of whether you have a complex schema or have an easy schema, your question might be complex or easy. So that's, of course, also something that the quality at the end will depend on. So the question is, how do we choose the right tool for the job? So there are many LLMs and many languages. So how do we choose? And there's a benchmark. There's of course benchmarks out there that can be done, and also the Time to Act group internally does benchmarks.
Yes, and these benchmarks, so you can find them on the link. These are not classical academical benchmarks, which are theory-based. These benchmarks are based on the extracts from the real-world business applications that we've seen deployed for our customers or for the peers in our AI research in companies in Europe and United States. And core tests, evals, and prompts from these benchmarks, they were extracted from the products. They moved here and grouped in different categories. And we've been running this benchmark to analyze performance of different models, essentially in real-world tasks of business AI automation. And we thought that that was Elena's idea to take this approach to benchmarking different LLMs and apply it across the sections to SQL and Cypher query engines. And the idea was that let's take a realistic business case. In that case, we took a business product, which is called Contexture, and it is a product of TimeTag Group Austria. It is inspired heavily by the domain-driven design in your community, and it is used by companies to document technical, organizational, and risk-based dependencies in companies. For example, it is used to document different departments, who is working on there, which systems are being deployed, what are the dependencies between the systems, who is responsible for maintaining which systems, what are the message flows, for example, what are the infrastructure dependencies, and what would happen if in the case of a breakdown. And as you can guess, the schema of this system is fairly complex. So if we take the abstract model definition in a Python language, for example, that is based on the contexture, and we just map it to a MERM QML, as you can see, there are lots of dependencies. There are circular dependencies. It's possible to go haywire. For example, we can have a mainframe that hosts a couple of business applications. And those business applications are maybe connected to each other through an enterprise service bus. And there might be a couple of other services which host databases on which some of the mainframe applications depend on. And there could be a web application that depends on that. And these different applications, different systems might be maintained by different departments and different people. They might be one maintainer, they might be multiple maintainers, and there could be risks in that environment. So we thought that this case, which is derived from the real world case, is good enough and complex enough to challenge LLMs in writing different queries. And if we take this model and, for example, project it to the graph database, so it might look like this one, for example. As you can see, this is a circular. There are circular dependencies. You can go into the recursion. And we believe that this kind of domain model, this kind of challenge, would be a good challenge both for our skills as LLM and AI engineers. And also it would be a good challenge in understanding which engine would work the best as a execution environment for the LLMs to write queries, execute them, and get the results. And to prepare the benchmark, so we took this domain model and we also created a canonic list of fairly complex questions and answers, which have known exact answers. For example, if a maintainer of the CRM system, if the only maintainer of the CRM system goes on a vacation and this CRM system fails, which and how many other systems in the company would fail because of that failure directly or indirectly? So maybe if there is a payment gateway that has 3 dependencies down the loop, then and if it depends on the CRM system, it should be accounted for. So these are the examples of different questions that we've prepared for the benchmark. And let's talk about different types of questions.
Exactly. So we've seen now that we've got the data, we put the data into a graph database and into a SQL database. And then we came up with some questions to be asked, of course. And we split the questions into different complexities to also see how well the LLMs perform in these different complexities. So a level 1 question, well, that's a very easy question that only touches one entity, saying, okay, like who is which is the birth date of some employee, for example, or anything like that, which only touches one entity. Level 2 questions, well, they already touch one or more entities which are one single hop away, so the direct relationships of this one node. Then we have questions that, again, touch the same radius of entities, but then maybe use aggregations with that, like a sum or a min or a maximum. Level 4 questions, well, they can already go further, so they go more than one hop away and use some aggregations. And then we have level 5 questions, which well, can be recursive queries or union of join queries, so even more complex queries. And let's look at some example questions. So Rinat already mentioned one, but these are the types of questions like for levels 3, 4, and 5, for example, that we implemented. So for level 3, for example, how many other systems have a direct dependency on this one system? So this is like one hop away, and then an aggregation. Level 4, well, how many systems have at least one owner and at least one maintainer from different departments? So that's already going more than one hop away because you have to find the departments of the people. And well, level 5 question, well, if some application failed, how many other systems would be affected? So this is a recursive query. You don't know how far you need to go in order to find out. And in our test set, we have 21 questions. So we thought we're not going to take level 1 questions. They're too easy. We're going to start with level 2. Also only have 1 in there, and then we have more questions for levels 3, 4, and 5. So that's it. We have the test setup. So we have the database, once in the Neo4j and once in the SQL setting, and we have the test questions. And now let's run them. So we started by just doing exactly that, and this is the first round of results that we got. So you can see that, well, it doesn't look so good. There are a lot of mistakes being done by the different LLMs, and well, you don't get such a good feeling if you look at that first. But let me also go through the models that we took. So we took some GPT-4 models into the benchmark. We also took a Mistral model, Quen model, which is the alternative here, a Claude model, a fine-tuned Llama 3 model, and of course a Gemini model from the Google family. Okay. Yeah.
And before we move forward, there was a question also about the benchmarks in the Q&A. So how do these benchmarks actually work? So we have a list of questions with canonical answers, and Elena showed them earlier. So we take each question and then we pass it to LLM. So essentially we make a text request to LLM, and it says something like that. Hey model, this is the database schema in which you're operating. Here are a couple of hints. Now, given the question that I'll paste you later, please reply with a properly formatted syntax query in Cypher or in SQL that can be used to execute and return the result that the user is asking for. So in essence, the benchmark is we take the database schema, we take user question, we combine them, and we ask LLM to generate a query that will help to answer this question.
All right, thank you. Okay, but I mean, we didn't want to be finished here, or else it would be quite boring. So what we did is look into what the LLMs are actually doing with our questions to see where we can maybe optimize things. So let's start with the Cypher part. So what's going wrong with the Cypher part? Here I'm going to pick out some questions and display the generated queries, and we'll have a look why this goes wrong. So first question, how many employees are listed as both owners and maintainers of the same system? So this is the part of the schema that we're looking at. And if you're looking at the Cypher queries that are generated by some LLMs, you'll see this. So it's querying for employees that are owned by the system, and the same thing with the maintained by. And you actually see that a lot, that the directions are not good. So the LLMs are quite bad at taking the right direction, even though they have a schema available which has the correct directions. Okay, you can also see that a bit differently in this other question here. So how many other systems would fail directly or indirectly in case of root optimization engine outage? So this is the part of the schema that we're looking at. So systems depend on other systems. And so we would like to know which systems depend on this specific system. And well, here it's basically the same story. So most of the LLMs will take the wrong direction. So they will say, okay, find this node in the database and then look for like things that this depends on, but actually this should be the other way around. If we go further, then we can find this one, for example. How many systems are there that have only one owner or one maintainer? And if you look at that, well, it looks quite good, but it's using this size operator here. And if you look at the documentation, then you'll see that, well, this is old syntax. It's not valid anymore after the version 5.0. So, well, it's failing on our 5.something database, of course, since this is not valid syntax anymore. And actually, this mistake is done by most models. There are only some that don't do it, but they do, sadly, other mistakes on this question, then, which doesn't give them any points in here either. Well, I also wanted to take a glimpse at some specific models. So if you look at GPT-4, for example, there are also some weird things going on, like this ID method here, which is somehow weird. And for example, here, the model is somehow bringing in a not into the name, which also doesn't work. If you look at GPT-4 Turbo, for example, then yeah, you have other things like you wrong brackets here, which should be curly. Or, well, here you have a question which says, okay, if someone is on vacation, what's happening? And then it's just inventing a new edge type, which is on vacation, which doesn't exist, of course. And yeah, these are the things that you have to deal with the Cypher. Let's look at the SQL side.
Okay, with SQL side, the mistakes were fairly common to any LLM that tries to work with complex databases. And first of all, the SQL syntax was not a problem, probably because it's established. It hasn't changed in a long time, and it is not developing very fast, unlike NeoCore-J. And because of that, I didn't have to embed distilled syntax instructions and hints into the prompt. I was able just to ask questions right away. And the question was that sometimes the LLMs, they didn't know which fields were relevant or not relevant. Sometimes it would take a user request too literally and write fairly complex queries. And could you show the second example? And another example, once again, the systems were confusing whether I was referring to the system by its name, like should be a name or should it be an identifier, and how to write proper filtering statements. Fortunately, this is all easily fixable, and how this can be fixed, we'll talk about later.
Okay, let's look at some more interesting queries. So for example, these recursive queries. So if you look at this question, for example, if the customer relationship management system failed while its maintainer was on vacation, how many other systems that depend on it would be impacted directly and indirectly? So basically, we're looking at dependencies which can be recursive. And if you look at the Cypher query, well, it's actually not that difficult because you have the star here, which says, okay, just go find all the systems that depend on this one system and count them up. Whereas the SQL query, of course, is a bit more complex since well, the syntax is more complex in the SQL space for these kinds of queries. And well, if you're looking at this one single question on this benchmark and look which LLMs were able to translate that properly into a language, well, you see that sadly, well, in the setup, the SQL, there was no LLM that could translate that properly to SQL. Actually, there were like 3 which could do that, and well, one just in brackets because just the direction of the edges was wrong. What's also quite interesting is that filtering seems to be a problem. So this was already mentioned by Rinat on the SQL side. So also on the Neo4j side, well, basically this is the problem that the LLM, of course, has. It's difficult for the LLM to figure out that it needs to do filtering if the filtering is not very obvious. So, for example, in this question, like how many systems would be without a maintainer? So basically, we need to find systems that only have Daniel Koch as a maintainer. And well, as you see here, yeah, there's not really good answers here in the different models. Just this one actually trying to find the systems where no other employee is maintaining it. All right. So let's look at the first round findings. So for the Cypher side, we saw, well, relationship directions are a problem. Actually, if you look at the GPT-4 solutions, they mostly don't use directions at all. Mistral is always using directions, but basically never gets them right. And actually, the Claude model is really good at directions. Then what I thought is also that passive relationships might cause problems, and we'll look at that a bit later. Filtering, we already talked about, and, well, the evolving Cypher syntax.
In case of SQL, and I'll talk fast because we have only 8 minutes left. So the biggest problems was that because SQL database is not designed for recursive queries, and with some of the questions require writing recursive queries. So the system can go haywire, and the entire query ends with the endless loop. So obviously recursive queries were a pain for SQL. Filtering was frequently a problem. And as I mentioned earlier, unnecessary database fields were used. Okay, let's see how this was fixed for Cypher.
Yeah, so we did something to fix stuff. So what the first thing I did was I looked at the results and thought, okay, what if we just ignore the directions? What if we just, like, if the only thing I'm doing is correcting directions? And then you actually see that if you take the results, then this is what you get. But if you just correct relationship directions and nothing else, then actually the results are pretty much better. And you can see, for example, that Mistral Large is actually doing a quite good job. But, well, as I said before, it's just getting all the directions wrong. And on the other hand, like, for example, Claude has been doing a really good job with the directions already. So there's nothing to change in terms of directions. So that's quite interesting. So my first remedy was, okay, let's just turn the passive directions around. So I'm not doing system owned by employee, but I'm doing employee owned system. I wanted to see, well, does that make a difference actually, or does it not? And here's the result that you get. And I was quite happy with these results because you see that it actually makes a difference. So I didn't change anything else. I just changed the direction of the relation and put it into active speech, not owned by, but owns. And this already improves a lot. For example, on the Mistral model, it just does great job on the active relations. And yeah, I already mentioned this. GPT-4 is not really using any kind of directions, so, well, it doesn't care. All right. So my second remedy, and maybe you already heard about this as well, few-shot examples. So I identified 4 issues, which have been, well, the passive relationships, the direction of the depends on edges, missing filtering, and we've seen that the syntax has evolved on Cypher. And so basically what I did is I added a few-shot example for every single one of these issues to see whether that helps. So in this case, I kept the passive relationships, but I just added a few-shot example to get this covered. And actually, this is also already looking quite good. So most of the models are still ignoring this syntax, even though I presented it in a few-shot example. But for example, but we see that almost every model is already doing quite good. So just by the way, these are not new issues. They're quite known. Neo4j is also introducing the Cypher Copilot. And well, these are issues that are already known. So going to the Cypher altogether. Well, if we've seen these results already, so I put them all on one slide. And if you're doing active relations plus Cypher few shots, then you actually get a really good results. And actually the Sonnet model is really good in doing Cypher, as we see. And let's quickly go to the remedies on the SQL side.
Okay, so let's switch to the next slide. that essentially handles a lot of questions that we have in the Q&A section. So why was SQL results so bad? And we basically need to look at the root causes of the LLM hallucinations. So LLM hallucinations, it's when LLM doesn't return the result that we expect it to. What it is can be done if we're using LLM incorrectly. For example, we're not using LLM as an information transformer, but we're heavily relying on some newly trained knowledge, which wasn't the case, for example, with Neo4j latest syntax. Also, LLMs will hallucinate if the signal versus noise ratio in the input context is wrong. It means that if I put too much junk into the context and too little relevant information, then I shouldn't be surprised if LLMs return junk results. And also, if the task is too difficult for LLM, that it will not be able to solve it. Because as Andrei Karpathy mentioned earlier, LLMs don't have a chance to pause and think that much. They have a limited cognitive capacity per token. So given that, I've done a very simple thing. Please switch to the next slide. So I've tried two optimizations. And because I have 20 years of development experience, so I know how to be lazy. So my optimizations involved asking ChatGPT nicely. Advanced optimization, I asked ChatGPT-4 to rewrite the SQLite schema to make it more explicit and verbose, drop unnecessary description fields. And simply, and this pattern has worked a lot in real-world cases. If you take the SQL schema, a relational database or not, and you make it more explicit, more verbose, then magically LLMs will be able to make more sense. And this improved results. Then I've done something even simpler. I asked GPT-01 preview, the latest one, to write the SQLite schema to make it easier for query complex dependencies. And I even cheated. I asked to introduce a SQLite view that can perform system dependency walking, ensuring that endless loops are handled. So, well, I didn't cheat. I just asked it to design the schema for the querying tasks. And what were the results? Please switch to the next slide. So the SQL basic implementation, when I was simply asked GPT-4 to transform the domain model into the SQLite schema without any worries. The advanced, when I asked it politely to make it slightly more verbose and coherent. And the full-scale implementation was when I asked GPT-01 preview to really think through and design the SQL schema, relational database schema, to make it easy for querying and to avoid common pitfalls. So it even created a helper view for the recursion. And it required, I don't know, like 5-10 minutes of prompting, and you can see the huge jump in results.
Yeah, so we need to wrap up now. We're running out of time, but this is the results that we had at the end. So, well, you see here the basic results that we had in the beginning and the results that we could get come up at the end. And I think they're already quite good. We see that for SQL, while GPT-4 is doing a great job, but also Claude and Gemini are doing really well. And on the Cypher side, Claude is our #1 winner, and with GPT-4 in the second place and Mistral in the third. So there are, of course, a lot of things that we could have done. Some of them are also suggested in the Q&A. So we could have used fine-tuned models, for example, a fine-tuned text-to-cipher model or a fine-tuned SQL model. We didn't get to that. Of course, we could have taken more data sets with diverse schemas and complexities and comparison of that across schemas. There's also the conjecture out there that translating correct queries from one language to the other might be good, but we didn't have time to do that either.
And my favorite pet peeve of the recent is using structured outputs, which is constrained logic decoding, which helps a lot in real-world projects. And we thought that if we actually constrained the output of a model to the abstract syntax tree representation for the proper syntax, so for Cypher or for SQL, then it will not make syntax mistakes at all, because it will be forced to fit into the schema. But we didn't have time for that. And also, obviously, using knowledge bases for the context-specific FIFA prompts.
And this is a summary, and thank you all for listening in.